let's start with the actual migration challenges. What we'll do now is we'll talk through the possible challenges that can occur. We will see how to fix them with the command line options that we just learned about. And then we'll have a live coding part where we'll apply this to a project that I purpose built to be broken in as many ways as possible. And you will have to help me there. So you will have to get your keyboard out and put the focus into the chat window, because I hope that you can help me go through that, and we'll see some error messages, and then you can try to map them to what I tell you now and help me give me tips on how to work around them. Okay? So in other words, this will be on the test. Let's start with the migration challenges. What do you have to look out for when you're running on, well, JDK 9, 10, 11? There's small differences there. There's only one non-trivial difference between 9, 10 on the one hand and 11 on the other hand. And we'll do the demo migration from 9 to 10 to 11, but you don't have to do that. I just do that to show you a couple of more details than I would otherwise be able to show you. If you're still on Java 8, it's perfectly fine to immediately go to 11. So just do that. No reason to try first 9 and then 10. So the thing is, there are tons of internal changes within the JDK for Java 9, and some of them might break your code, even without modularizing the application. And that's a very important part, right? As I said, up to now we've been in the world where everything is on the module path. We don't do that anymore. Now we just take, okay, we just discussed modules, and we thought about modularized applications, and we mainly did that so you have a mental model of how modules work, because the modules are in play within the JDK. But your code does not have to be modules to run on Java 9 or later. Your class path application that works on Java 8 can work just as well on Java 11. You don't have to create a single module, but it can break for reasons that are mostly related to the module system. And these breakages occur whether you build modules or not. Okay? So it's very important. It's not the modules. You don't have to create modules, but if you don't, whether you create them or not, you might run afoul of some of these issues. There's a good chance, let's stay here for a second. There's a good chance that you will see none of these problems. I will talk about later what you should do, but the gist is update all the things. If you can now update all your dependencies in all your tools, specifically now in 2020, you have a good chance that you can just bump your compiler target from 8 to 11, and you will not see a single of these problems. I'm going to go through them, so in case you cannot update a dependency, or a dependency is no longer maintained, or you use one of the rare projects out there that still don't work properly, so that you know what you do. But ideally, I could just cut this short with update all your things, bump the target, and then it just works. And there's a good chance that this is true for your project, right? So what I will show you now is the collection of all the things that can go wrong, and we look at the project. As I mentioned, it's purpose built to break. Don't take this the wrong way and we'll be like, oh, all the migrations will be this hard. They won't. Some of them can be even harder though, so you never know which one's your case. So that's what I just told you. The modularized JDK and your legacy jars, legacy meaning, right, regular plain jars without module declarations, they have to cooperate, because that's what backwards compatibility means, right? If you have jars that don't do anything they shouldn't be doing, then they should just work on Java 9. The problem here is that the module system really wants everything to be a module. But for compatibility reasons, your jars have still to work on the class path. So how do we fix this? This is where the unnamed module comes in. What the module system does is, if you put stuff onto the class path, so in this scenario, all of your jars are on the class path, but the JDK, of course, is in modules. So the way these interact is that the module system takes the stuff that's on the class path, puts it into a big box, calls it the unnamed module, but it doesn't call it the unnamed module. Because if you call it the unnamed module, it sounds like the name is unnamed. But that's not the case. It doesn't have a name. It's the module that shall not be named. It turns into a box, writes no name on it, actually, and makes it into a module. And then the module system still functions, because now everything is a module. The class path stuff comes to a module that has no name, as I mentioned. It reads all the other modules and it exports all its packages. And the last 2 points are there for maximum compatibility, because nobody knows what's in the unnamed module. Nobody knows what other modules it needs. Nobody knows what packages it might export. So it reads all of them and exports all of them. Now remember that it reads all modules does not mean that it can access all of their internal APIs. It reads just means that it can access any types at all. And whatever crazy thing you do on the class path, like, hey, we got Guava in 3 different versions there and it still kind of works and all that kind of stuff, that still keeps working within the class path. So the idea was to leave as many things as possible in place on the class path. The big challenges are these 4. The changes to internal APIs, JEE modules, which is my handy way to sneak around the Java EE, Jakarta EE thingy. I mean, now they're Jakarta EE modules, but back then they were Java EE modules. So those kind of modules, what happened to those? The split package situation, or split package, yeah, the problem that you can have there. And then finally, runtime images and related stuff. And let's go through this. What's an internal API? Well, every package that starts with sun.something, and most of the packages within the JDK that start with com.sun something, they're internal APIs. We should never have been using them. And we did it for quite some time. Oracle even trolled us by pulling out some page from like 1999 where Sun was like, you cannot use these types. and the entire ecosystem went, who cares? So we've been using those a whole lot. Many of the classes that, well, a whole lot. It's not like they're like in every import, right? It's not like they're present in every class. But with a whole lot, I mean that most projects out there that, or at least in 2017, almost no project out there did not have a dependency that would use this. Like all the great dependencies, like all the Spring Framework, Hibernate, Mockito, all the mocking frameworks, they were all using these kind of internals. So that's not ideal. And so the decision was made, everything I just told you means you cannot access this, period. Not at compile time, not at runtime. If you take a Java 8 jar that does this and put it into Java, like that accesses JDK internal code, and put it into on Java 9 JVM or Java 11 JVM, you would expect it to just break. Okay, that will break a whole lot. So the decision was made, okay, let's not do that quite that hard. What we do instead is, if you compile against the JDK 9 or later, then you will not be able to compile against these internal APIs. Asterisk, I'll come back to that in a minute. But if you build on Java 8, and there were back then, you should not have been using them, or we should not have been using them, but if we did, we can then take that Java 8 jar, put it through Java 9 or 11 JVM and run it, and then it can access these internals. If you use reflection to go to the internals, you get some warnings. They are unfeasible for strict bytecode dependencies, so you don't get anything there. But yeah, there you go. So you can still access them at runtime for your old code. But if you want, so that means if you have a Java 8 build and you just want to run the tests on 11, then you have a higher chance of passing than if you also want to build against 11, meaning compile against 11. But I would still recommend to build against 11. We'll come to that in a second. Well, not in a second, but we'll come to that later. Okay, the small asterisks I just mentioned, there are very few APIs that were deemed critical, meaning there is no good replacement for what they offer, and a lot of the ecosystem depends on it directly or indirectly. Chief among them is SunMISC unsafe. If you just hide SunMISC unsafe, a lot of stuff out there will break. And if you replace all of usages, whatever, all the places where SunMISC unsafe is used with the proper public APIs, a lot of things will have a huge performance degradations, or just lose features entirely. Okay, so SunMISC unsafe survives a while longer. The JDK team has since been busy providing public APIs that replace part of SunMISC unsafe, and the idea is that it gets shipped into ever smaller pieces, and at some point it will be gone because everything that's used is in a public API. What can you do to find these? First and foremost, you can use JDEPs. I'm not going to go into detail of JDEPs, but I'm going to mention it a couple of times. JDEPs is a command line tool that was shipped since Java 8, actually. You will find it in your JDKs or the JREs, well, not your JRE most likely, your JDK's bin directory. On Java 9 and later, the difference between JDK and JRE is basically vanished. You will find the bin directory just next to Java and Java-C and Javadoc. So it's a command line tool, and it does dependency analysis based on bytecode. You throw a bunch of bytecode in it, and it will just go through that, scan it, build dependency trees, stuff like that. And it has a bunch of flags. And what I tell it here is, I tell it, look, start with this jar here, which is a project that a friend of mine is maintaining, Scaffold Hunter. Start with that jar. And then I put all the dependencies into the libs folder, so please use that as the class path. And recursively search through that. So it starts here, starts with the Scaffold Hunter jar, and then analyzes each class. What other classes does it depend on? And recursive means if you step outside the Scaffold Hunter jar, don't stop, but go on. Go all the way through all the dependencies. And this flag means all I care about is tell me whether I use internal APIs. And then you get output like this, where you see, for example, that Bartik codec jar uses something that's removed. More specifically, the JPEG image writer uses JPEG codec. JPEG image writer this is the class out of Bartik codec jar. This is a fully qualified class name. I just cut it short so it fits on the slide. So it will tell you exactly what you're using and tells you, by the way, this is gone. So this is not even hidden, it's just gone. And this can happen every time. Every minor release can refactor and remove and move around internal APIs, right? So that's why you're not supposed to use them. And this will tell you this is gone. Then apparently Guava's class stripped 64 uses unsafe, and then Scaffold Hunter itself uses Windows Combo Box in Java Desktop. So you will get this kind of output. So you can analytically find code in your jars, but also in dependencies that use internals. But it doesn't find reflection cases. That's a bit of a problem because reflection is based on strings, so it cannot be. In general, it cannot be analyzed without running the system, and that's not good. So what it does then, it checks. You have to do that actually. You have to look for calls like class for name, for example. Class for name will not fail, but it's often the entry point to reflection. The calls that will fail is set accessible. The method set accessible on the class accessible object or interface. I think it's interface. That method, that's the one that will fail if you try to break into an internal API. If you use reflection to break into internal API, then you will usually have set accessible true calls. What you can do with set accessible true is there's a private field. I still want to read it. So you get the field, use reflection API to get access to that field, to get a handle on that field. And then you call set accessible on it and tell it, like, I know it's private, I don't give a damn, I want to make it accessible. And these calls will fail in the multi-system, with the multi-system in play. And yes, you would have to check that for your dependencies too, but it's probably easier to just run your test or run your application and see it. So what do? If it's your code, you have to fix it. If it's a library, you have to contact the library developer and maybe open an issue or upvote an issue, or maybe even try to contribute a fix. If all of that doesn't work because maybe the version is old, the project is not maintained anymore or whatever, you have to start looking for alternatives. Maybe there's a JDK API that does that. Maybe there's another dependency that you have to use. These are the proper long-term solutions. Fix your code and help the maintainer fix their code. But what you can do in the short run is use command line flags, like add exports and add opens that I showed you earlier, and a legal access, I'll show that later. You can use these command line flags to break into this API. But remember, that does not fix the underlying problem. It's still an internal API. It can still change every day. And that means your code can still break with any minor update. That's why we're not supposed to depend on internal APIs. So these things are really a marker for, these ones. Hey, come on. There you go. For technical debt. This means technical debt right here. So that was the first one, internal APIs. The second one is shorter and more straightforward. What about JEE modules? So Java EE is separate from Java SE, right? When we're talking about JDK, we're usually talking about, or Java in general, we usually talk about Java SE, Java Standard Edition. And there's a bunch of APIs that were never part of Java SE and yet they were shipped with the JDK. The reasons for that are complicated, but that was the case up until Java 8. So for example, the Java Activation package, that's in the Java Activation module. Java transaction was in Java transaction module, and then the entire JAX WS was in JAX XML WS, and so on and so forth. These 6 modules contain Java EE APIs. And these were in Java 9 and 10, you can use these modules, and I'll show you later, but they are removed in 11. So in 11, these modules are no longer there. And if you want to find that out, you can use JDEPS. You can tell JDEPS to build a dependency tree, and then you can see on the right-hand side is any of those one of the removed modules. And what can you do to fix it? That's a short-term fix that works on Java 9 and 10. And I'm going to show it to you just because it's fun and we can apply a couple of command line options. But this should not be your not only not your first choice, it should just not be your choice. Pick a third-party implementation instead. This is a link that leads to a Stack Overflow question that I asked about that, and we collected a bunch of implementations in the answer. This does not mean that this is the best implementation. It just means it's a implementation. It's just one that works, or an implementation rather. So replace these Java EE APIs if you have been using them, and chances are that you have if the project is not very small, then there are fair chances that you have been using them. Replace them with a third-party implementation as a regular dependency. Works wonders. Okay, now we get to a third problem, split packages. And this one is very special. It's a rare problem, but it's also a really devious problem. It's probably the most devious that the entire migration and module system has to offer, and I would say by far, because it doesn't tell you about itself. If you use an internal API, the module system tells you. If you use a module of the deprecated Java EE APIs, the module system will tell you. Like, it's very verbose in its error messages. You get a lot of useful information out of it if you understand it at a decent level. Even if you don't yet understand it at a decent level, it gives you error messages that you can start looking for and searching for in Stack Overflow and stuff. So those problems are kind of fixable. There's a path from I have that problem to my solution. Split packages are really devious. The error message will not tell you at all what's going on. And here's what's going on. The idea is that every package should belong to just one module. Okay, so if you have a package called comfoo bar, then only one module should contain classes in that package. The rule is no module must read the same package from 2 modules. Technically, that leaves the option that you have a split package, but it's just never exposed to the same module. But never mind, because that's not what the implementation does. The implementation is no 2 modules must contain the same package, and it doesn't matter if they're imported or not. That means if you have 2 modules and both contain types in the same package, they don't have to be the same types either. Just comfoo is the package, and then you have a class A in one module and comfoo class B in another module. Both of them contain types in comfoo, and the module system will not let you launch. You will get an error right then and there. That will not be allowed. And that error case is very verbose. We'll see JDEPS in a second, but also Java compiler and the JVM will tell you, look, you got a split package. I'm not doing this. That's fair enough. The problem is, if one half of that split is on the class path, the module system will not tell you that I have a split package, but it will not see the path, the part that's on the class path, and you will just get no class def found errors at runtime. This really sucks if that happens, because what you basically get is like, I cannot find this class, and you're like, wait, why? Where does it come from? And you find out, wait, the class, it comes from that dependency. And then you look at that dependency and like, wait, the dependency is there. It's on the class path. Why would you not find that class? I mean, come on. And then, okay, the reason for that is that I mentioned earlier that modules are exposed to a couple of checks, like the reliable configuration sees where all of them are there. It checks in a couple other things as well. One of them is it checks split packages, and if it finds them in these modules, it tells you about them. I also mentioned that the class path, the chaos of the class path, is allowed to live on in the class path. So the class path is not exposed to any checks. And that means if the module system scans the modules and finds out that comfoo, the package com.foo lives in that module over there, it will know that whenever it looks for a type, in that package, it goes looking into that module. So when you now look for a type conf_foo that's in the module, it will see, oh, it's a package conf_foo. I'm looking for a type in there, so I know it's in this module. Let me scan that jar. There the type is. Everything's hunky-dory, there you go. If the type is not in that jar, it will do the same thing. We'll not find the type here, and then it's like, well, but the package belongs to this jar, so the type should be in here. It's not in here. I can't, like, it's not there. Like, it doesn't even check the class path. Okay, that's bad in the sense that it's really hard to analyze. And honestly, I think an error message would be better there. I think the JVM could do better and could then, if it doesn't find it here, could then check the class path, because it's already a no class def found error. It's very likely this will crash the JVM. I think this is not too much to ask from performance-wise. Check the class path and be like, at least give you an informative error message, right? It should still crash. I still agree that it's not a good case, but should at least tell you about it. Okay, so why would this ever happen? Why would you split packages? So first of all, somebody might do this on purpose, right? For example, I've seen code where somebody wanted to use an internal Spring API, and the API was there, just it was protected. It was in a protected class, on a package visible class. What do? Well, that's easy. You just create the same package in your own code, put a class in there that accesses the internal API and makes all of it public. It happens. And if code does that, and you start modularizing your own application, then you will find that problem again and again. At the moment, in the beginning, when you just move to Java 9 and later, it can only happen with code where part of that is in a jar and the other part is within the JDK. And that is rare, but it's not non-existent. So for example, the Java XML packages are split between the JDK, and this is from Xerxes, I think, XML APIs, this project. Then some JBoss modules split a bunch of bunch of packages, but that's mostly okay because they're meant to replace the modules that contain these packages, or rather they can also be third-party implementation of Java EE modules. So this case is mostly okay. And then we'll come back to this case later, because JSR 305 does something that I think, strictly speaking, is actually against the Java community process and probably even a license violation, because JSR 305 contains these null annotations. The JSR that wanted to introduce them never did actually introduce them. And I think then by license, they're not allowed to use the Java package names, but they do. So the JAVAX annotation package exists within the JDK and also exists within JSR 305. And we'll see that in a second. Or not in a second, but in a couple of minutes. And you have to remember that we'll get back to that, as I mentioned. If you use JDEPs in whatever form, whatever you put here, whether it's summary or look for JDK internals or whatever, if it finds split packages, it will tell you about it. Like, you will get a block of all the split packages it found right in the beginning of the output. So it tells you that within the Java runtime, there's this module, only 9 and 10, but still. And in the libs folder, there's this jar, and they split this package. So JDEPs is your friend here. So what do you do about that? If those are your artifacts that split a package, you have a ton of choices. Right? You can rename one of the, like, let's say you have a large application with tons of jars and you want to turn them into modules, and while doing that you realize that you split your own packages. Then there are tons of options I mentioned. You can rename one of the packages, you can merge them, one package into the other, right? Maybe you have to merge the artifacts. If none of that works, you can keep both of them on the class path because, the chaos lives on there. Both of them on the class path, that's important. So you have options. Otherwise, if it's, for example, a dependency of yours and the JDK module, your options immediately go down to 2. One of them is, and you don't have a choice really, one of them is, oh, the jar that I have here is actually an implementation of a module within the JDK. Like, it's a full re-implementation, for example, of JUXWS. That's great. Then you just go, I'm show you, I mentioned it later how that works. It's called the upgrade module path. You just tell the JDK about it and be like, okay, look, or the JVM, replace that module with this jar, and then you're done. Then you don't really have a split package anymore because the module is not present. You just use the jar instead. But if it's not a full replacement, this is where patch module comes in. This is where you have to say, oh crap. So I have this module, I have this jar, both of them have to exist. They split a package. Okay, I tell the module system to pretend that all the classes within that jar actually belong into that module. I add them manually with patch. I patch those classes into that module, and that's very ugly because if this jar has dependencies, then I'll have to read the module, and the module have to read the dependencies down here. So you have to. It's not a good case to be in. Okay, let's go through a couple smaller changes fairly quickly, so we can actually go to and see the breaking stuff.